Hello and welcome to the RNA Nanostructures Science Gateway presentation. My name is Dan Thibodeau. I'll be presenting with Daniel Schur today covering our project. So the Holland Computing Center is the research computing resource for the University of Nebraska. The product that they wanted us to design was they wanted us to develop, implement, and deploy a comprehensive science gateway for the design and optimization of RNA nanostructures powered by RNA-Make. So the sponsor stakeholders are Derek Weitzel, Hongfeng Yu, and Joseph Yesselman. Joseph Yesselman is the professor that created the RNA-Make application, which is a resource that allows researchers to input a PDB that can be expanded upon. A PDB is a RNA molecule file structure, but they can input a structure that can be expanded upon, and then RNA-Make will run different iterations of it and produce results with those iterations. So you can see all the different kinds of ways it can be expanded. Hongfeng Yu is an associate professor of computer science and engineering, and Derek Weitzel is the primary sponsor contact for us. He's also a research assistant professor of computer science and engineering. The development team, our project manager was Melanie Kugler-Wright. Tribe lead was Brady Garvin. Development manager is Daniel Schur, who will be talking later. I'm the project manager. And then our developers were Al-Farouk Al-Salti, Connor Elliott, Evan Palmer, and Josh Siemens. So, as I've said previously, the problem was that RNA-Make, the application created by Joseph, requires a large amount of command line knowledge to be effective. And this can pose a significant challenge to researchers trying RNA-Make's design algorithm. It's not very accessible.
They had a break over by Grandpa's Woods, right there by Rex's garden.
Okay. Our solution was we wanted to create, or we were tasked to create a web science gateway that presents users an easy to use interface to submit RNA-Make jobs to the open science grid compute resources and view the results in an intuitive way. Now, Daniel will talk more about how we executed that solution.
Yeah, so the solution that we had built, we implemented the Science Gateway by using an off-the-shelf, not necessarily off-the-shelf, but it's an open source software stack called Apache Arvada. Apache Arvada is a job submission framework, so what it's meant to do is it's supposed to be able to manage users' submissions of jobs to run on high-performance computing resources, and taking certain inputs and data as well, and then passing it to different compute resources that are configured to then run on those resources. And that works in conjunction with a web framework that's built on Python's Django web framework along with Vue.js. And this creates a comprehensive science gateway then that can be used. And so to be able to actually execute this solution, we had to extend Apache Arvada to be able to submit jobs to the Open Science Grid, since the Open Science Grid uses a different job submission format than like HCC or any of the other formats that were already supported by Apache Arvada. So with the help of the developers of the Apache Arvada project, we were able to extend their interfaces and also make pull requests to the project. So it's now actually now in their project, and it can be used by other people who uses Apache Arvada for science gateways as well. Aside from that, so that covers a lot of the back end. On the front end, another thing that we had to also implement was file validation. And so when a researcher, for instance, inputs a PDB file, we wanted to make sure that the PDB file is correctly formatted. That way, the researcher never is able to run a job on a malformed PDB file that would not be able to be run on the actual compute resources. So this makes sure that a researcher who decides to use RNA-Make doesn't waste resources and time submitting jobs with malformed PDB files, since this could be caught early. But once a researcher actually runs a job, then and they get back their new designs of the PDB files, which is RNA molecules. It was also wanted that we would be able to have a way to be able to show off the molecule in a visual format in 3D. And so we had to integrate a molecule visualization into the front end as well, so that you can view the experiment outputs. And we also want to implement a table to view a little bit of statistics on the outputted designs. That way, if a researcher were to say create 10 designs or something, they can easily see a brief overview of different aspects of how RNA-Make ran on those designs, so that they can easily know which designs might have been the best for their use case, or how those came out without having to really delve into the deep parts of the file to really kind of analyze what's happening. Yeah, so the first thing that we were able to do and really polish up is make a landing page for the application. And so this is the first thing that a researcher would see, for instance, and they can see the supported apps. Currently, the main one that we were working with is Design RNA Scaffold. With that, then, a researcher, for instance, would be able to log in or create an account to be able to then get into the Science Gateway. Next slide, please. And once a researcher has been able to get logged in, they are then greeted with a interface where they can see the different applications that you can run. A nice thing about this framework is that if, say, Joseph decides to create more sub-applications that a researcher should be able to run through RNA-Make, he can then extend the interface and add more applications. The current one that we were working on was Design RNA Scaffold. So a researcher would be able to click on that to be able to create a new experiment. They can then, for instance, on the left side, you can see the application configuration. That's where the researcher would input their PDB file that they want to design from, along with the starting and end base pair, and how many designs they want to create. The interface is also extensible, so for instance, Joe would be able to extend what attributes could be modified by the user. So if sequences was something to be modified, they could do so, or any of the other command line arguments that could be extended to be able to allow a user to modify those if wanted. But with the defaults, then if you run the experiment, you go ahead and select to run it. It ends up running on the Open Science Grid. And so it passes back the files with all the configurations. It runs it on the Open Science Grid, and then the new designs get passed back. And so an example output is shown here on the left, with the right side showing some experiment statistics, which is the actually run job. With that, a user then is able to look at their previous experiments. So they can click on different experiments, see the outputs, or see why an experiment failed, for instance. They can then also kind of go back, and then if they say ran 10 experiments, they can maybe go back to the first one and be like, all right, what were the outputs of this one compared to the first one or something. So they can kind of flip between experiments and see what they ran, their job submissions. And then if an experiment were to succeed, they would be greeted with this sort of output that they can view. And so you're able to select the different drop-down, different designs that were ran and visualize those in 3D, and the visualizer is interactable, so you can actually click on it. And then this is an example of the table output. And you can also hover over some of the columns and change the different visibility of columns. And so from this project, we gained a good number of value, and there were some highlights of the project as well. The team, for instance, gained a lot of experience in web development and gained exposure to web development frameworks. Most of us are computer engineers, so we've done a lot with low-end type development, a lot of hardware, a lot of back-end type things, so a lot of this was new to us. The team was also provided significant exposure to contributing towards large open source projects. We worked in conjunction with the Apache Foundation with the team at Indiana to be able to get a lot of this done. And the team also gained experience in working with multiple external teams to accomplish a goal. So, yeah, thank you for coming to our presentation.
Nice job, guys. How might this project have changed your, when you think back of where you started at the beginning of the year, how might this project have changed what you thought you would do in the future?
Personally, I'd probably solidifies a bit more of my want to work with a lot of the lower end back end type things, because I'm not a huge fan of working with designing UI systems and things like that. And so having this sort of experience of kind of seeing the process of working with a lot of web development and stuff has made me realize that that's probably not necessarily for me personally. But a lot of other good things that I've also learned from it is that working with other organizations on open source projects is actually a pretty fun thing to do. And it's really nice to be able to contribute back to the community and have things that I build that other people will then be able to use in the future as well.
Awesome. Let's give a round of virtual applause to our presenters, either through the clap emote or just through the chat is fine. And that marks our final presentation for the day. Thank you for anyone who joined us through the any of the presentations. It is much appreciated. And thank you to all our presenters who presented.
Great job, guys.
Thanks. Guess we'll get back to our table, although there's not much to show off at this point now since everything's wrapping up.
Yeah, everything's kind of wrapping up, but yeah, thank you. See ya.
See ya.